Okay, let's give this a go then. Using the nspire for unfamiliar functions. So this is going to be a key skill for this second functions unit. And so what I thought I'd do is put together a little video on kind of how some of it works. First bit of advice is to make sure what you're inputting into your nspire matches exactly to whatever you're seeing given as a function here. So we're going to start off, you might have this screen, you might have this one, but we're going to start off by just putting in a function, putting in a graph page. So here we want 3 plus, and then if I want to create the fraction symbol, it's above that divide sign, so control and divide, and then it gives me that nice chance to put a numerator and a denominator. So 1 over, and I don't really need this bracket, but what I'm going to do is put it in there because it's there on the question. X squared, then, oh, it seems to have caps lock on, let's just undo that. X squared minus 4x plus 3. And here we can see what that graph generally looks like. Now the first thing then, in order to make it as accurate as possible, is to ensure that what we've got matches all of the points on here. So obviously the question starts at -1, but my window starts at -10. There's a couple of ways of changing this. You can kind of double click on that, but that's quite tricky to do on the handheld. So the easier way is to menu graph, window zoom, and window settings. So I want my X value to go from -1 up to 5. So here we have -1 up to 5, and I want my Y values to go from -3 up to 8. -3 up to 8. And we can see this is what we're looking for on this graph. Now it doesn't quite look how I'm expecting it, and I'm just noticing that I've made a mistake. There's a squared term here. It doesn't look like I've got a squared term on mine, so I'm just going to change this. It's got to have a squared term, and here's what it actually looks like. Okay, so that's the general shape, and that's what I'm going to put in first. So we've got a nice, beautiful, sloping and rising. We've got a nice hump down the bottom, which comes up to here and then goes back down. And then I seem to have another slope coming from up high and down, something like that. And I think it starts a little bit, oh, that's a bit large, starts a little bit, needs to be a little bit flatter than it was. There, I'm quite happy with that. Remember, it's just a sketch, doesn't need to be perfect. Okay, so let's include some details on this. First of all, I want to include the y-intercept here. What I'm going to do is I'm going to take my Control T, and I'm going to look at the table of values that I've got here. Now for the y-intercept I want x to be 0, so I just need to go up, and it's 3 1/3. Just from that highlighted cell. Okay, next I want to show my x-intercept, so Control T, and let's menu analyze the graph, and we want to know where it goes through 0. So we get this funny lower bound it's saying, and this dotted line that's following my cursor. What I want to do, if I want this x-intercept, I've just got to click below it and then go above it, just so that the computer, so that the nspire knows which one I'm after. And there it is, 1.18. So that's 1.18. Whoops. 1.18. And then we obviously need a second one. I might move that out of the way. It's going to get a little bit congested here. I might move this down as well. Can't do it there. But if I get that hand icon, there it is. And let's do it again. Analyze this graph to find the 0. So my next x-intercept is at 2.82. Okay, let's answer the questions then. Write down the equations of the 3 asymptotes. Hopefully, our table of values is going to give us our asymptotes. So let's have a little look. Control and I pressed tab, didn't I? I meant control. So let me just escape that. Back to this. We don't need a second one. So Control and T. Now anywhere it's undefined, that is an asymptote. So my asymptote here, we can see it's having that asymptotic behavior. It's going off to infinity and then coming back the other side of infinity, wherever that is. But we can see that that's happening here. It's undefined at x equals 1. So that's the graph that I just dotted on, x equals 1. So that's going to be at 1. Difficult to sometimes show 1 on a dotted line. Next one, again, you can see undefined at x is 3. So that's going to be this one. So there's a 3 there, x is equal to 3. And then there's a final one, and it's a horizontal asymptote. And we've got this asymptotic behavior. The graph is tending towards a point but never reaching it across there. Best way of finding that I know of is to press the down arrow on this table of values and see what happens when we start to put in some large values. And you can see it's getting towards a certain value for y, but it's never ever going to reach that value. And that value, if you look at it, looks like it's going to be 3. So y is equal to 3. Okay, local maximum point then. Let's close this table of values. So that was Control and T. Now the local maximum is going to be at the top of this hump here. So let's analyze the graph. Menu, analyze, and we want the maximum point between two certain points. And again, we need to go to the left of the point and then to the right, and you can see what happened. You can't really see it there. It increases until we get to that maximum point. My graph is starting to go back down, so it's settled on that maximum value. So my maximum point here is 2, 2. Okay, final question then. The line y equals x intersects this curve at 3 times. Find the values. Okay, so we need to plot y equals x. To put a second function in, that's when we press the tab button. And we just want y is equal to x. There it is. Now we've already got one of these. We've got it at 2, 2, and that makes sense because x is equal to y. So we know x is equal to 2. That looks like, looking at the graph, it looks like my middle one. So I need this one here, and I need this one here. Similar process, menu, analyze graph, and we want the intersection now. Okay, same process to the left of the one we want, to the right, 1.38. And then the final one, menu, analyze graph, the intersection between here and here. There's one up here which is 3.62. Okay, moving on. So I need to dock and insert a new graph. It's always worth inserting another graph because then we can kind of refer back to this when we're checking our work later if we need to. So next function is this 9 minus x squared, and we need that in modulus. So that's going to be, I think, this button here next to the 9. We get this modulus option, the absolute value of 9 minus x squared. Beautiful, there it is. Okay, change our axis again. Menu, window zoom. We want the window settings. X from -4 up to 4. And I want the y from -10 up to 10. Okay, now it looks like it should on my graph. So what I've got is this lovely shape coming down like our normal quadratic does, and then it's jumping up here. It's a little bit difficult to control, and we've got that. Hopefully that looks kind of something like what we're expecting. Okay, I'm interested in a couple of points, so let's analyze this graph. Let's find out where the zeros are. So there's one here at -3, and there's another one. Menu, analyze graph, to 0 between here and here. That's at 3. Oh, so it is a nice symmetrical shape. The y-intercept, we did Control T to find out when x is 0. So x is 0. What's happening at y? That's 9. Okay, so that's this point here. Right, let's see what it's asking us to do. On the diagram, sketch the graph. Yeah, we've done that. That's at part A done. Solve f of x is equal to 7. So the easiest way of doing that is going to be to, where's my table of values, to plot the graph of y is equal to 7. So that again is tab and 7. Look at that. Okay. So what have we got? We need the intersection. So menu, analyze graph and intersection. Now I wonder if there's one down here. Looks like it's out of our range, so let's just go up here and across. Minus 1.41. So x equals minus 1.41. And the second solution is going to be at menu, analyze graph, intersection, between here and here, and it's positive 1.41. X equals 1.41. Okay, so the equation 9 minus x squared equals k has two solutions. I'm just wondering, this is making me think. I'm thinking that we have got some more solutions here. So let me just have a little look at the table of values to get a better picture of what's going on. So Control and T. What I'm worried about is this thing here going to give me an intersection of 7? Well, yeah, looking at this, I'm getting a value of 7 here for minus 4. So that's right on the range of the. So I couldn't do in the analysis because the analyzed graph, because it didn't quite go down that far. But I'm getting more solutions. So let's write these down as well. So x equals minus 4, and the other one place where it equaled 7 was at 4. So x equals 4. So we've got 4 solutions for this function of x equaling 7. And that makes sense in many ways, because what we've got is we've got it cutting through here, and you can see there it's cutting my axis at 4 separate points. So now, what we're interested in is where could we put a line to give us only 2 solutions? Well, only one of those that I just drew was going to give us 2 solutions, and it's where we go above that point there, right? That's going to be the crucial point. So let's go back. Menu, no, sorry, tab, no, Control T, yes. No, it didn't work. Control T. Oh, I need to escape what I was in. Control T, there we are. And I'm interested in getting values for this graph to be above that point there. So if I can work out what that point is, it looks like it's 9, but let's just double check. Menu, analyze graph, and we're interested in where's this maximum point here. For this graph, between here and here, and you can see it is at 9 that we were expecting. So if I want to not intersect the graph 4 times, then I need 1 up here. So it's going to intersect once and twice over here. That's going to be for values of k that are greater than 9. So k has got to be greater than 9. Okay, next one. Doc, insert, graph. Let's do this. Absolute value of, now we've got 4x squared minus 9. Lovely difference of 2 squares, hopefully you spotted that. And let's plot it, and then let's change our axis. Window zoom, window settings, minus 2 up to 2. And here I want to go from minus 10 up to 10. Okay, very similar looking graph. So let's draw it. We're coming down. Oh, no, not down that way. Curving that way and then going up and over. Down again. It doesn't look great, does it? Let's just make this one a bit longer so there's a bit of symmetry there. Marvellous. Okay. Right, what we asked now. Find the x-coordinates meets the x-axis. Okay, we can do that by analysing this. We want where it's going to be 0. So that's going to be here at minus 1.5. And I reckon there's probably going to be some symmetry. 1.5, marvellous. So minus 1.5 and 1.5. Similar question, the line 3x minus 2 intersects it twice. Okay, so let's draw that. Tab 3x, what was it? 3x minus 2. It does intersect it twice, you're not wrong, here and here. So we want to know the y coordinates. Oh gosh, that's okay, fine, y coordinates. Menu, analyze graph, and we want to know the intersection between here and here. Now I've got a y coordinate of 1.98 if I round. 1.98. And I've got a second one, menu, analyze graph, intersection 3.25. Okay, find the value of k where the line y equals k meets the curve exactly 3 times. Okay, so very similar question to before. If we cut here, we get 4 solutions. If we cut up here somewhere, because we know that this is carrying on, I'll just draw it on here. We know that this is carrying on. But if we were to intersect up here, it's going to be 2. There's only one specific place where it cuts 3 times, and that's on that maximum, that local maximum. So let's find out what that is. Menu, analyze graph. If we want to find the local maximum of the green graph between here and here, it's at 9. So the specific point where it cuts 3 times is going to be the line y is equal to 9, or k is equal to 9 from this. Find the range of values where the line meets 4 times. Okay, so we said that 4 solutions was down here, wasn't it? I'm cutting the 4 times, but we need to not count things down here because that doesn't intersect it at all, does it? So I need my values to be for k from 0. Now it has specifically 2 solutions at 0, so it can be equal to, but it's got to be less than 9. Marvellous. Onwards. Question 4. Doc, insert a graph. What do we have now? We've got a fraction, so that was control and divide. What have we got? The numerator says x squared, and denominator consists of another x squared, but also a minus 2x and a minus 3. What a beautiful looking function. Okay, let's get our window correct. Menu, window zoom, window settings. We want to go from -5 up to 5. And the y, I want to go from -4 up to 4. Very similar shape. We didn't miss a great deal previously. Let's try and draw this. So I think we've got something coming here and going up. Something coming from here. Something going on around here. I'm not sure if it does go above the axis. Doesn't quite look like it, does it? Hard to know. We'll probably find out very soon. And then this as well. Okay. Equations of the 3 asymptotes. Okay, let's try for this again. Control T. Is there anything undefined? There's something undefined here at x equals 3. So looking at my graph, that's going to have to be this one. So answer, x is equal to 3. And I can put a 3 on here. Next one, looks like it's negative. So let's go up then, see if there's any more. Oh, there's one undefined here, -1. So this one, x -1. And then the horizontal asymptote, where we're going to put in large values for x. Is it getting close to a number that it never actually reaches? It looks like it's getting closer and closer to y is equal to 1. So y is equal to 1. And y is equal to 1. Okay, local maximum. This is similar to what we've done before, isn't it? So Control T. And I want a menu, analyze this beautiful graph. Where is the maximum point between here and here? Or local maximum is at 0, 0. Marvellous. Local maximum 0, 0. Local minimum point. Okay, so might not be obvious, but it looks like there might be a minimum point here somewhere. It's kind of might be coming down. Let's just see it. Give it a go. So analyze the graph. We're now interested in a minimum. I'm going to go all the way down here because it's hard for me to see. And you can see it is going down still, and then it's going to go up again. So it's going to settle on a point. There we are. -3, 0.75. Local minimum, -3, 0.75. Solve the inequality. Where is it greater than 3? Okay, well let's just plot in 3 and then have a look. So tab. So where is my graph greater than 3? Well, it looks to me like there's 2 points that is greater than 3. Up here and from here. Now, in both those situations, I need to know what the intersection is. So let's go for analyze, find the intersection. Okay, and the other one, menu analyze an intersection between here and here. Okay, so for it to be greater than 3, what I'm interested in is from this point here up to my asymptote, because after the asymptote it goes below 3 down here, and then all the way here it's below 3, and then from this second asymptote at 3 it then stays above 3 until we get to x is 4.098. So how are we going to write that? Well, we need x values from this first intersection, which I've got as -1.098. That's x is greater than, because it can't be equal to here, x is greater than that, but less than the asymptote, the first asymptote, which was at x is -1. And then in the second region, which is from the second asymptote, the x is equal to 3. So 3, but it goes up to then this intersection I've just established, the 4.098. Marvellous. Onwards. How many of these have we got? Oh, only a couple more. So question 5 then. Doc. Insert a graph. Control. Make it a fraction. I've got 1 minus 2x. And I've got then an x minus 3. Beautiful. Make the window look like the axis on the graph so that we get the scales about right. So x value -6 up to 4, y from -12 up to 12. Okay, beautiful. We've got this lovely shape coming up here and going up to infinity, and then we got something coming down and across here. Beautiful. Sketch the graph done. Write down the equations of the asymptotes. Okay, so Control T. Do we have a nice undefined? We do, and that's happening at x is equal to 3. So let's draw that in. 3, x is equal to 3. And then the horizontal for big numbers, where's it going close to? Never reaching. Looks like -2. So across here, -2, and y is equal to -2. Find the range of values for y when x is greater than or equal to 0. Okay, so where is my function greater than or equal to 0? Well, it looks like just this section here, from this root up to the asymptote. So I'm interested in where that root is. So analyze the graph at 0, and it happens at 0.5. So I want values for x that are greater than 0.5 or equal to, but it has to be less than my asymptote, which is at 3. And is this the last one? Yeah, one more. We got time for one more, haven't we? So doc, insert a final graph, and we've got a beautiful absolute value graph, it looks like. I don't need that controlled. So Okay, right, I've done something wrong. Let's just get this. Okay, right. Absolute value of, now we've got a fraction within it. 1 minus 2x, which is in a bracket, and that's over x plus 3. Beautiful. Window zoom, get this right again. From minus 6 up to 4, and from minus 12 up to 12. Oh, look at this. What a beauty. Right. Now, what does it look like? How am I going to draw this then? It looks like we've got a lovely sweeping curve going up here. We've got something coming down from there. It's going to cut through, it's going to hit my x-axis and then kind of bounce off. That looks alright to me. Solve the equation, where is it equal to 6? That's quite easy for us to do with all of our skills. 6, there it is. Where does it equal to 6? Menu, analyze the graph, intersection. From here to here, minus 4.75. And I'm up to menu, analyze graph, intersection between here and here, minus 2.125. And that's us done. I really feel like I want to put this on here though, as if I'm in the test or anything. Let's just do one more, shall we? Analyze the graph. Let's find the 0 of this graph between here and here. It's 0.5. It's quite a nice thing to label, isn't it? As with the y-intercept b, so let's just make sure that we're including everything. So this comes through at a third. And we're done. Worksheet done. Hopefully that's helpful to show you how you use your GDC to help you with this type of question.